When the airplane, gliding through the air, smoothly approaches the ground and then touches it at a speed of 250 kilometers per hour, the most critical and tense phase of the flight begins: braking. This is undoubtedly the moment when every passenger, with a flutter in their chest, feels the full power and grace of this magnificent machine. Just a few seconds separate the roaring giant, whose mass can reach tens or even hundreds of tons, from a complete stop. It seems as if the pilot simply pressed the brakes, and the plane, like an ordinary car, gradually slows down. However, behind this brief moment lies incredibly complex engineering work, where every mechanism and every fraction of a second play a decisive role. To grasp the grandeur of this process, imagine a passenger liner races down the runway faster than a Formula One racing car. But unlike the race car, it needs to stop not over kilometers of distance, but in just a few hundred meters. And all this happens without skidding, without sparks, and without losing control. How does such a massive machine manage to accomplish what seems impossible at first glance? First of all, it's worth knowing that brakes on an airplane do exist, and they are installed directly on the landing gear wheels. But these are not the simple brakes we are used to seeing in regular cars. Here we are talking about a high-tech system capable of withstanding hellish loads. At the moment of a landing, the temperature can rise above 1,000 degrees Celsius, enough to melt metal. To combat such incredible heat, multi-disc brakes are used, which are compressed with incredible force using a powerful hydraulic system. The pressure in this system far exceeds that in automotive brakes. However, this is only part of the problem. If the plane relied solely on these wheels, they simply wouldn't hold up. Even the ultra-strong tires could burst under such a load, and the brake discs would glow white-hot. To avoid such a scenario, engineers developed a cooling system. In some aircraft models, built-in fans are used to blow air through the brake units, which helps dissipate heat more quickly. And on the most modern liners, carbon brakes are installed. They are lighter, stronger, and much more resistant to extreme temperatures, capable of withstanding hundreds of landings in a row without replacement. But even the most advanced brakes are just one component in the large deceleration mechanism. The real magic begins the moment the wheels first touch the ground. Listen to the sounds of the engines at that moment. They suddenly start roaring even louder. It seems as if the plane is accelerating instead. But the opposite is true. Thrust reversal is engaged. This is one of the most amazing principles in aviation. The engines, which just pushed the plane forward, now direct the airflow in the opposite direction. Using special flaps, the exhaust gas flow is redirected forward, creating a powerful force opposite to the direction of movement. It's as if an invisible hand grabbed the plane and tried to hold it back, preventing it from rushing further down the runway. This system is so effective that on some types of liners, it can completely stop the plane without the help of wheel brakes. But thrust reversal cannot be used for long. As the speed decreases to a certain level, the engines must return to normal operation mode. Otherwise, there is a risk of damaging their internal components. Therefore, pilots act with surgical precision, literally in a matter of seconds, using the reverse and then switching to other systems. And here another hero of the landing comes into play: the spoilers. These movable panels, located on the upper surface of the wing, rise immediately after touching the ground. Their task is to destroy the lift that kept the plane in the sky. As soon as it disappears, the entire weight of the liner transfers to the landing gear, and the brakes begin to work at full strength. In addition, the spoilers create additional aerodynamic resistance, like huge brake shields, slowing down the movement of the body. Without them, the landing would be significantly more risky, as the plane would continue to float above the runway, reducing braking efficiency and increasing the risk of overshooting it. Thanks to the combination of three braking systems, thrust reversers, and spoilers, the airliner can decelerate with the speed of a sports car, but with the precision of a Swiss watch. And all this happens in just a few seconds, while passengers feel only a slight jolt and hear the roar of the engines. Under the fuselage, the coordinated work of hundreds of mechanisms unfolds. Every detail, every valve, and every sensor contribute to slowing the aircraft down exactly as needed. Stopping an airplane within the distance of a runway is not just a technical process, but a true engineering marvel, honed over decades of testing and innovation. And while this is already impressive, engineering thought does not stop there. What happens if the aircraft's wheel brakes or thrust reversal system suddenly fail? In such a situation, it seems that disaster is inevitable. However, engineers have anticipated such cases. Even without these main systems, there are methods for safely stopping the aircraft. Some airports have special emergency surfaces that resemble a dense, spongy mass. When the wheels enter it, the kinetic energy is gradually dissipated, allowing the airliner to slow down without damage. In military aviation, runways often have foam-covered surfaces that reduce friction and help cushion landings in emergencies. These measures can be crucial when brakes fail completely. But this is just the tip of the iceberg. In the world of aviation, there are airports with runways so incredibly short that they require pilots to demonstrate impeccable skill and top-notch piloting. Take, for example, the famous airport located on the picturesque island of St. Martin in the Caribbean, where planes land literally over the heads of tourists relaxing on the beach. The distance to the end of the runway is minimal here, and even the slightest miscalculation can result in a catastrophe, threatening not only the lives of passengers, but also the safety of those nearby. Or consider another example, the airport on the Portuguese island of Madeira, whose runway is partially elevated on concrete pillars reaching into the sea abyss. In this airport, pilots must demonstrate incredible precision to land the plane at the very beginning of the runway, leaving enough space for safe braking. However, this is just one of the amazing aspects that many laypeople don't even think about. Did you know that airplanes almost always land against the wind? This is not just a whim or coincidence, but a strict law of aerodynamics. The headwind acts like an invisible helper, serving as a natural brake by creating additional lift, even at low speeds. This allows the aircraft to approach the ground more smoothly and slowly, without risking losing stability at a critical moment. The stronger the headwind, the shorter the rollout after touchdown, significantly reducing the time and space needed for a complete stop. If an aircraft attempted to land with the wind, the approach speed would be significantly higher, and the rollout distance would increase by 1.5 to 2 times. That is why runways worldwide are oriented to allow pilots to land in the safest, most reliable and energy-efficient way. Now think about it. What other mode of transport on Earth uses such complex systems just to stop? For cars, everything is straightforward. Brakes on the wheels, whether disc or drum. Trains are equipped with pneumatic or even magnetic brakes, but their operation is also quite straightforward. An airplane, however, is a completely different matter. Here, everything is built on the complex interaction of mechanics, aerodynamics, physics, and advanced computer algorithms. Each system works not in isolation, but in a unified symphony of precision. Modern airliners literally think during landing, redistributing efforts between brakes, thrust control, and aerodynamic surfaces, proving that aviation is one of humanity's most technologically advanced achievements, impressive not only in the sky, but also on the ground. Next time you are a passenger and feel the gentle bump of the landing gear on the concrete strip, remember that stopping is the result of the complex, synchronized work of dozens of mechanisms. Reverse thrust redirects air, powerful hydraulic brakes hold the wheels, and spoilers on the wings instantly reduce lift, forcing the plane to firmly adhere to the ground. All this happens simultaneously with millisecond precision. Without this perfectly tuned coordination, any flight could end quite differently. But even this is not enough. Planes can decelerate even before their wheels touch the runway. Before landing, pilots reduce speed using spoilers in descent control mode, and finally adjust engine power. This skill requires incredible attention and experience, as it is necessary to slow down the machine without losing control and stability. Without these aerial maneuvers, many landings would be too dangerous, especially in adverse weather conditions. One of the most impressive examples of pilot skills occurred in 2017 at Düsseldorf Airport, Germany. On that day, a giant Emirates Airbus A380 was landing during a severe storm. The wind blew with such force that the airliner approached almost sideways, battling the currents until touchdown. But thanks to the crew's skill and the precise operation of all systems, brakes, spoilers, and reverse thrust, the plane was able to stabilize and come to a complete stop without incident. Footage of this landing spread worldwide, becoming a symbol of the importance of the coordination of all braking systems and the high professionalism of pilots. Now imagine what it's like to land not on a concrete strip, but on the deck of an aircraft carrier. Combat aircraft in such extreme conditions must go from a speed of 240 km per hour to a complete stop in just a few seconds. For this, powerful arresting wires and special hooks are used, which catch the aircraft upon landing. Even the slightest mistake in a fraction of a second can result in the machine going overboard. These scenes are vivid proof that braking in aviation is a true art, requiring precision, knowledge, and courage. Now that you know how it all works, does it surprise you that stopping an airplane requires overcoming several laws of physics at once? Did you realize how complex this task is? Every landing and every skid mark on the runway hides incredible stories of human genius and engineering mastery.